Select the cactus and let's return to the geometry nodes. Let's go inside one segment and then further inside segment positions. Recall how the start and the bottom of the segment have a center, a radius, and a tilt. So 3 for the start, 3 for the end. We're going to add one more degree of freedom for the start and the end, called the twist, which is a rotation around the long axis of the cactus. So we can go to our start tilt input and add a new one below that called start twist. And the same for the end tilt. We can add a new one below that called end twist. Those are going to need to be inputs to the position vertex nodes, so let's go and edit those. Give them a new twist input. And what we're going to do is copy the vector rotate node. Its output is going to be the input to the second vector rotate. This vector rotate here is the one that does the rotation around the tilt axis. This one is going to do the rotation around that long axis of the cactus, which in this context is just the vertical axis. So you can see the axis of rotation is by default 0, 0, 1, which is the vertical axis, so we don't need to change that. But the twist value is the angle. The center remains at 0, 0, 0, and the value coming out of scale here is the vector that we're rotating. And of course, we clean up. Let's come back out of here, and let's plug that start twist and end twist into the position vertex nodes, and then clean up. Let's come back out of here, and let's go to the inputs and add some new ones. Specifically start twist and twist severity, both of which are floating point values. Likewise, for the outputs, add end twist and twist severity, also floating point values. Twist severity can be wired directly from the input to the output. And let's make a little space. And let's compute the end twist by adding twist severity to the start twist using a math node and the add function. And let's give it a reroute point so that we can label it. Now bring end twist up into line with start twist and wire it all the way through to the output. Next, let's make sure we get start twist and end twist fed into our two segment positions nodes. Specifically this node and this node. Now we're ready to get these two values flowing through all of the segments in the cactus. So the only one that we need as an input to the overall cactus is a floating point value called twist severity. And then we do the usual plumbing. And notice that we've left the start twist on the first segment at 0, which is just fine. Let's take a quick look. Here's our cactus. Let's set our twist severity to 0.2. And if we change it, we can see how it affects the twist on the cactus. Now at the moment this is a uniform twist because of the way we're using twist severity. Later we'll change that so that it's more randomized to give the cactus a more organic look. Let's start doing that by addressing how we're going to generate random numbers. So there's already a node in the geometry node system for generating random numbers. But I'm going to do things differently because what I want is I want these random numbers to be based on the location of the cactus. So that if I want multiple cactuses, I merely need to copy a cactus, move it to a new location, and I get a different cactus. So with that in mind, let's prepare some inputs for a random number generating node that is going to help us determine what the end twist will be, instead of just adding twist severity to compute the end twist. Let's do it with a bit of randomness. So in fact, let's get all the way out of here and let's add a new object, just an empty. And let's name that empty object for RNG, short for random number generator. And so positions in space relative to this object are going to be what drives our random number generation. So we're going to go back to our object or our geometry node setup. Come back into here, and yep, let's prepare the inputs that we want. First of all, we want the ID. That way we can have different random numbers for the different segments in the cactus. We also want the start twist and the twist severity. And then finally, we want that object. But it's not yet an input, so let's create it as an input. It's of type object, and we're going to call it object for random number generator. We will also have it as an output. And we'll feed it all the way through from input to output. And bring it here for as an input. So we've got the inputs that we are going to need for computing our end twist value using some randomness, but we're going to have to create a node for this. So as usual, I'm just going to add two nodes, right click, group them, delete them, and now we can create a node any way we wish. Let's start with the inputs. Let's make the first one the initial value. What we're going to do is generate a random number that takes an initial value and then moves it a little bit up or a little bit down. And so let's call that first number the initial value. The second input will be the magnitude, that is how far up and down we're willing to deviate from the initial value. The third input will be our object for the random number generator, so that's type object. And the next will be a W value, and yes, this will be a W because we're going to be using a four-dimensional noise to generate our random numbers. And then finally, so we can have different numbers within the same segment, we're going to have one more value called the W offset. And we'll have only a single output, which will be the new value. first thing to do in here is to compute the actual W value that we will use for the noise texture. So let's bring in a math node using the add function. And this is very simple. We just add W and W offset together. Next, let's bring in an object info node and plug in our object for random number generator. Set it to relative. Next, we want white noise. And we're going to plug the location value of our object into the vector input for the white noise and switch it over to 4D. And then we can plug our W value into the W socket on the white noise. Next, let's get both positive and negative versions of our magnitude value. So for that, we're going to need a math node set to the multiply function. We're going to multiply by -1. And let's rename this node to times -1 for short. And now finally we want a map range node. The value input on our map range node comes from the value output of our white noise. From min and from max can remain as 0 and 1, but 2 min and 2 max should be the negative and positive magnitudes respectively. And then finally we add the initial value to the output of the map range node. And that's the final output of our random number generator. Let's get out of here and let's give this node a name. I'm going to call it the +/- random number generator. Now we can plug in the inputs that we need for computing our n twist value. So initial value is start twist, magnitude is twist severity, object for random number generator is object for random number generator. The ID is the W, and we can leave the W offset as 0. And what we're going to do is every time we use a ± random number generator node within the same segment, we'll just give it a slightly different W offset. And that way each node gets a different random number. Let's label the output. And let's replace the n twist that we computed here with a new one based on randomness. That's all the wiring we need to do inside this node. Let's do the wiring outside the node. So specifically, we need to get this object for random number generator and feed it through the chain of segments. So let's have it as an input to our cactus. It's an object. Let's stick with the same name, object for random number generator, and plumb it through. And then let's get back to our layout view and let's give that object as an input, object for random number generation. And let's put our twist severity up to 0.2, and you can see how we have a random variation in the twist. And it becomes more extreme if we crank up the severity value. So let's just drag it down to a value that just, prevents the cactus from being perfectly vertical in these ribs that run up and down the length of it. Look a little bit more organic. Also notice that if I grab the cactus and move it, those random numbers change and we get a different amount of twist. And in fact, all of the randomness that is going to feed into the shape of this cactus is going to work in this way. So that if we move our cactus or if we copy it to a new location, we get a completely different cactus. The next bit of organic randomness that we're going to add is to change this perfectly even spacing between the buds. So what we're going to do is have each bud shift up by a random small amount. Also, you'll notice that when we go from a large segment to a smaller segment, there is an obvious gap because the final gap on the large segment is large compared to the first gap on the small segment. It stands out. So shifting the buds around a little will help hide that to some extent. So let's drill down into our node system and let's get all the way to our spawn exsect node. Let's get inside there. And the reason we're going inside here is we're going to add one more output. So we have the geometry, we have the vertex, and what we want is, in addition, we want the index of the vertex. All the vertices in a mesh in Blender have an index. We're going to use that as part of our input to our random number generation system, so that each vertex is a bit different. So that is going to be of type integer, and let's call it index. To be clear, let's call it vertex index. And the way that we get that is with a capture attribute node, the same way that we got the position of the vertex, but it's an integer, not a vector, so we swap this over. And then we just plug in the geometry like that. And in the same way that there exists a position node, there also exists an index node for this purpose. So we can plug that in. And then we can feed that as our new output. Let's come back out of the spawn exsect node. Tiny bit of cleanup. And we want that vertex index to be a new input in our segment position node. And we actually want a couple other new inputs for this node as well. So let's go in there, pull up the panel. And I prefer to put the vertex index at the top. So let's copy vertex position, move it up, change its type to an integer, and rename it vertex index. And then down at the bottom there are a few more things that we need. So we need that object for the random number generator. We also need a W value. And we need a Boolean called slide. The reason for slide is we're going to be sliding the buds up and down to displace them from their rigid placement that they have now. We do want to do that for the buds. We don't want to do that when we're constructing the overall structure of our segment. So we're going to have a Boolean here that lets us turn that functionality on and off. So now we can wire vertex index into the node. Since this is the segment position node that controls the buds, we do want to enable the slide functionality, even though we haven't created it yet. And over here, we do want to leave it blank. Next, let's wire in the object for the random number generator and the W value. With those inputs having been plumbed through to the segment positions node, let's go inside that node and let's move the inputs over here, and we're going to drag the values that we need down into this area where we'll do our computations, beginning with the vertex index. Followed by the object for the random number generator and the W value. and then the slide boolean. And now we're going to create another input, but rather than having it as an actual input, we're just going to have it as a constant. We're going to call it the slide magnitude, and we're going to give it a value of 0.1. So add a value node, name it slide magnitude, and give it that value. And then extend it vertically down just like the others. Next, let's add a math node. And let's set it to the multiply add function. And have it multiply by 50 and add 20. This is going to be the W offset value for a particular bud. So we'll have 4 of these, 1 for each bud. And they'll each have a different value in the final socket here. And this is just going to help make sure that each bud slides a different amount. So we can plug our vertex index as the value input on this node. Now we can add one of our plus minus random number generator nodes and line it up so that the W offset lines up with the value from the multiply add node. Here we have our object for random number generator and our W value. Let's plug them into the corresponding sockets in our random number generator. Now the gap between buds on a segment is 25% of the length of the segment. And what we're going to do is pick a new position within that gap for a particular bud. So we're going to go halfway up that gap. So we're going to put a value here of 0.125. And then we're going to be to either side of that. We're going to allow the random number generator to pick a value that's within 0.1. So we can plug our magnitude into the magnitude socket of our random number generator. Next, let's add a switch node. This is what's going to allow us to turn the slide functionality on and off. Instead of working with geometry, it's going to work with a floating point value. And we're going to plug our random number generator output into the true socket for the switch node. And of course, our slide boolean is the switch input. We'll leave the false value as 0, since when we don't want to slide buds, we're going to slide them by a distance of 0. And now each bud is actually at a different position along the length of the segment, as you may recall. And so what we've generated here is a position within a gap of 0.25 along the length of the segment. We just need to shift that up to the appropriate place for the particular bud. Right now we're working on nodes for the very first bud, and so what we're going to do is add a value of 0 to that. I know that doesn't do anything, but we're going to be consistent. We're going to add 0 this time. On the next one we're going to add 0.25 and then 0.5 and then 0.75. I could just leave this node out, but I like the consistency. Let's rename it to be plus 0. Now these 4 nodes need to be copied 4 times. And then we just plug in the wiring. We can delete the trailing bits at the bottom. And then we need to make a few small adjustments so that each of the buds is different. Recall that this one adds 20, let's add 40, 60, and 80. And then over here, let's change these to add 0.25, 0.5, and 0.75. So the outputs from these 4 nodes are the new positions of our buds, rather than the original positions. And all of these computations here just provide a random amount of sliding. Let's tidy up these nodes and make them a little more compact before we continue. We need to use these values in the places where we were previously using 0, 0.25, 0.5, etc. So, for example, here, in these midpoint nodes, not the last one, because there is no bud that goes on the last one, as you may recall, but the first 4. So let's connect these to the corresponding sockets here. And we should also connect them to the map range nodes that compute the scale for the buds. Let's take a look at the effect that this has. So we can see that the even spacing of the buds is now gone. Each bud is shifted on its own in a kind of a random way. In fact, this might be a little bit too extreme for my liking. So I'm going to jump over to the geometry nodes view where I can still see the cactus. And I'm going to find that constant over here. And you may be wondering why I didn't make this into a proper input that's plumbed all the way through the cactus. And yeah, I don't have a good reason. I guess I'm being inconsistent after talking about consistency earlier. Anyway, let's modify this value and see if we can find a better look for the cactus. That'll do.